Hello and welcome to our next section in our triangles unit 4.3. We're talking about proving triangle congruence by side, 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 and side, angle, side, also shorthanded as SSS and SAS. Go ahead and freeze or pause the video as needed. Get that title in. Same thing as this title, 4.3 triangle congruence once again. And let's jump into it. So here I'm going to draw something in pink. You do not have to copy this down. This is more so just a breakdown of how to navigate through a triangle. Now, a triangle has 3 sides and 3 angles. For the sake of simplicity, I'm going to call this A1, A2, and A3 for the angles. And I'm going to call the one opposite of angle 1 because of the angle pair relationships, or angle side relationships. This is going to be side 1. This is going to be side 3 because it's opposite of 3. And then side 2. Okay. Now, every angle is going to be sandwiched between 2 sides. Okay. Likewise, every side, let's actually use this one, is going to be sandwiched between 2 angles. So when you think about it, it's kind of like if you were to connect these pieces, the S is in the middle. Or if you were to connect these pieces, side, angle, side, it goes in that order. So the angle is sandwiched between the 2 sides. You cannot wrap around until you actually hit the angle. And that's how we navigate around triangle congruence, is that we need to know that every side is between 2 angles and every angle is between 2 sides. And when we're talking about side, for instance, side, 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 we're actually only talking about these particular sides because there's only 3 sides in a triangle. Okay, but when we're talking about side, angle, side, when we navigate through it, we talk about in order specifically the side, any side really. So for instance, this one. Let's say if we were talking about these 2 sides as being the first and the third, then the angle that is between them has to be A. It cannot be A1, I should say. It cannot be angle 3 because there's a separate side and a separate angle that is also between them. So it is the shortest distance around, or the sandwich between, okay? So when we're navigating through a triangle, we are talking about things being kind of in between or sandwiched between sides or angles, or you'll see what I mean. All right, so there goes that mini lesson on how to navigate triangles. Let's delete that, and let's talk about side, side, side. So the SSS, or side, side, side theorem, also known as the side, 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 it states that if, and notice this is an if, 3 pairs of corresponding sides of between triangles of corresponding between 2 triangles are congruent, then the 2 triangles are congruent. And remember, when we're talking about triangles being congruent, that means all of the corresponding sides are congruent, which this clearly states, but also all of the corresponding angles are congruent. So that would be the extra piece of information here. Okay? So the way to actually navigate this is we have to first have 2 different triangles. So let's go ahead and draw that. Now, it doesn't quite matter, for instance, if I redrew this triangle kind of upside down, it doesn't have to be the same orientation. What has to happen, though, is that we have to be able to recognize, okay, for instance, let's call this A, B, C, and let's call this one X, Y, and Z. We should be able to recognize, okay, let's say AB had a length of 1 tick. It could be any length we want it to be. And let's say XY also had 1 tick. That means AB is congruent to XY. Okay? We could also say BC has 2 ticks. And then we could also say, for instance, YZ has 2 ticks. So right away, these two sides are congruent. We have 2 pairs of sides that are congruent between 2 different triangles. But is this enough information? No, it's not, because the theorem clearly states we need 3 pairs of corresponding sides to be between 2 triangles to be congruent. So this third set also has to be congruent. 1, 2, 3 with XY, or XZ, I'm sorry, 1, 2, 3. And the moment we have that third pair is when we could say these triangles officially are congruent. Okay, so we would say triangle A to B to C is going to be congruent to, and notice this is really, really important. We have to name this triangle exactly the same as the corresponding parts. If I were to look at this angle A to B to C, angle A is currently between sides 1 tick and 2 ticks, and 3 ticks, I'm sorry, and we need to name it in the same position. So if you look at X, that is also between 1 tick and 3 ticks, so that is the corresponding angle, okay? Or if you want to think about it another way, we could talk about what sides we're going through. So, well, let's continue. Actually, let's finish talking about this thought. B is between 1 tick and 2 ticks. Y is between 1 tick and 2 ticks. So those would be corresponding angles. So we could actually name this triangle XYZ because of the fact where these are positioned. If you notice the last piece, HC is the first and the third letter. XZ is also the first and the third, and they both have 3 ticks for that particular side. The other way to think about it is this. Okay, if I go through, if I name ABC ABC, that means I'm going through sides 1 tick and then 2 ticks to name the triangle ABC. The third piece doesn't quite matter as much because it completes a triangle, yes, but ultimately we're naming it by just ABC once we hit all 3 corners. Okay, we could do the same thing by going through 1 tick and 2 ticks. This is the only way you could name this triangle XYZ to match up with the ABC. Now, by technicality, you could also call this triangle, for instance, BCA. This can be congruent to triangle, and then we have to correspond this properly. B to C to A. So if we went in that order, B to C is through 2 ticks. C to A is 3 ticks, and we need to follow that same order when we name this particular triangle. So we need to go through 2 ticks, and then we need to go through 3 ticks. So to go through 2 and then 3, it needs to follow this pattern. So we could say technically triangle BCA would be congruent to triangle YZX. This is the most important part to name for the triangle congruence statement, okay? So both of these are correct ways to name this triangle. There's a lot of different ways to combine combine the triangle names, but it's important that we name the second part properly. So this is going to be triangle ABC is going to be congruent to triangle XYZ by SSS, and that's all we have to do. Okay, so, and technically we could do it here for this one too, same thing, by side, side, side. All right, so the other theorem that we need to talk about is the side-angle side theorem. The side-angle side theorem. Side, angle, side. And what this states is this. If 2 pairs of sides and 1 pair of included angles between 2 triangles between two triangles are congruent. So right away we have two pairs of sides, one pair of angles of the included angle. Then the two triangles, I should say, then the two triangles are congruent. Okay, so here let's draw one. And I'll draw this one a little bit more straightforward. So let's call this one DEN. And then let's call another triangle KAC. Okay, and let's draw some ticks. Let's say DE is one tick, and then DN is two ticks, and then angle D has one tick. Okay, notice that this is side angle side, so that means the angle is between two sides. And in this particular case, it is. This is between the two sides that are ticked, right? So this is what we call the included angle. Okay, and then if we do this on, let's say, the other triangle, let's say one tick, two ticks, and then this K would be the included angle, then we could say that these two triangles in particular are going to be congruent because this is what the theorem says. If two pairs of sides are congruent and one pair of included angles, so that the sandwiched angle, then the two triangles are congruent. Okay, so here we could state, for instance, we could go triangle DEN is going to be congruent to triangle, and then notice we went from the tick mark that goes through, or the angle tick, through the one, and then through the no side tick. There's nothing marked on EN. If we follow that same pattern, we start at the angle, go through the one tick, and then go through the no tick. It follows the same pattern. So we need to follow the same pattern when we name that second triangle. The first triangle ultimately doesn't matter the order we write it in. What's important is we write the corresponding parts in the second triangle. The triangle KAC is all of the corresponding parts lined up, and this would be by side angle side. Okay, so that is it for today. Make sure you, if you have any questions, make sure you ask them during class. We'll get a ton of practice with this, and that's all. I'll see you in the next one. Bye.